Hi, Algebra 1. We are starting our last chapter, which we're just going to dab into just a little bit on Lesson 12.1. Chapter 12 is all on quadratics, which you've already done a lot of quadratics. Quadratics are something with an x squared. So you've done a ton of factoring quadratics. You've done a ton of different quadratics. So just remember that quadratics are with an x squared. So we are on quadratic equations with perfect squares, and your mean math teacher made you memorize all of your perfect squares and cubes for this reason and for last chapter. Our essential question today is, can you solve equations involving perfect squares? And yes, you can. So let's go ahead and start with example 1. Example 1 says 9x squared is equal 121. In your gut of guts, I know you're saying, oh, just divide by 9, Miss Maloney. You are correct. We are going to divide by 9. So what we have over here is x squared is equal to 121 over 9. And in your gut of guts, you're saying, oh, if you have an x squared, you can take the square root of each side. Remember, anytime we're solving for a variable, in this case x, we have something that was squared, we are going to have plus or minus. So the perfect square of 121 is 11. The perfect square of 9 is 3. So in this case, x is equal to plus or minus 11 over 3. They're going to start looking a little different though. So let's go ahead and look at example 2. Example 2 looks a little different because notice that we have parentheses and then something squared. So in your gut of guts, you should say, ooh, to get rid of that squared, we are going to take a square root. And remember, whenever I solve for an x squared, we are going to have a plus or minus, and the square root of 100 is 10. So when I add 3 to each side, this is literally saying x is equal to a positive 10 plus 3, and x is also equal to a negative 10 plus 3. Do we have to solve? Yes, we actually can solve these. 10 plus 3 is equal to 13, and negative 10 plus 3 is equal to negative 7. So in this case, sometimes you'll see x is the set of numbers negative 7 and positive 13. I never just mind if you circle them and tell me what it is. I'm not a picky teacher, but just make sure some teachers will expect that of you. All right, I'm going to move on to this one right here, example 4. Yeah, you know what? I'll go ahead and show example 3. If I divide each side by 7, and we have x plus 8 quantities squared is equal to negative 4. Remember that something squared will never be negative. Now, how can I assure you of that? When I take the square root, you have x plus 8 is equal to the square root of negative 4. Well, we have not worked with what we call imaginary numbers. So at this time, you will just write no solution. All right, example 4 might be the ones that kind of get you. When solving, we do have to make sure that all of our problems are equal to 0. In this case, it is not. So we have to bring the 16 over by subtracting. So we end up getting m squared minus 10m plus 9 is equal to 0. This is not a perfect square, but you do know how to factor. The factors of 9 that add up to be negative 10 are going to be m minus 9 and m minus 1. Because remember, these two numbers, negative 9 and negative 1, multiplied to be positive 9 and add up to be negative 10. So from here, we can solve m minus 9 is equal to 0 and m minus 1 is equal to 0. Therefore, we have two solutions again. 9 and 1 are our two solutions for m. All right, the last one that I'm going to go over is this one right here on example 5. Notice there's a ton of stuff around the perfect square. So this is the perfect square that we're looking at. We want to get rid of everything around it first. So just like you would in Algebra 1, the first thing we would do is add 4. So we get 6 times x plus 9 quantity squared is equal to 36. And in your gut of guts, you're saying, hey, divide by 6. And we get x plus 9 quantity squared equals 6. Well, from here, I know you just told me, Miss Maloney, that we could take the square root. But 6 is not a perfect square. So don't let that bother you. Remember, we've been working with radicals, so we're just going to show this as plus or minus, because again, we're solving for an x squared. X plus 9 equals plus or minus the square root of 6. And when I subtract 9 from each side, careful how you write it. You'll have the negative 9 first and the radical 6 at the end. So the solution is right here. X is equal to negative 9 plus and minus root 6. Great job.